guys, welcome to the 73 Technologieplauscherl. Today it's going to be in English because some guys in the audience are not native German speakers and the talks are going to be in English as well, so let's stick with English for today. I have one announcement to make. Today Ed Burns couldn't make it to Linz. He's stuck in Cologne, his kid is sick apparently, so he says apologies and we'll try to organize a different meeting maybe next year where he's going to show up and tell us something about Asia. Anyhow, we still have two very exciting talks today. One from Lukas, he's going to talk about BDD and how it's going to be used in Celum, I guess. And afterwards we're going to have Rainer Struppek, he's going to talk about Rust and going to compare it the memory management, I guess, yes. And afterwards, after the two talks, we're going to do the networking, if that's okay. All right, so that's it from my side. René, quick introduction of Celum, please.
Okay, thank you. Actually, if you don't mind, I would do it in German, so that everyone can, to keep it simple. Ich freue mich sehr und heiße euch willkommen bei Celum zum Technologieplauscherl. Wir haben es ja vor 1,5 Jahren das letzte Mal geschafft, Host zu sein und sind natürlich froh, dass es heuer doch noch geklappt hat. Und nachdem es schon so lange her ist, darf ich eben ganz kurz über Firma Celum berichten. Und zwar bei Celum geht es um Marketing-Content und Teamwork. Das heißt, wir bauen eine Content Collaboration Cloud, wo wir Brand Content oder Product Content verwalten. Das heißt, verwalten heißt mit Berechtigungen dafür sorgen, welche Personen im Unternehmen haben Zugriff auf die Dateien, Zugriff auf die Assets. Und wir sind sozusagen der Logistik-Hub im Unternehmen, um die Dateien zu verteilen und sicherzustellen, wie diese Dateien verwendet werden können. Und der zweite Bereich ist unser Work-Bereich. Das heißt, wir wollen natürlich in unserem sehr produkt- und auch bildgetriebenen Prozessen die User unterstützen, wie sie jetzt mit diesen Bildern und Assets umgehen können. Das heißt, ein Part davon ist File synchronisieren, das heißt, wie kriege ich aus der Web-Applikation die Files auf mein Notebook, um sie mit den nativen Applikationen zu öffnen. Und zum anderen, wie kann ich die Dateien und die Assets sharen mit anderen. Das heißt, zum einen natürlich im Unternehmen, wie share ich das? Nicht jeder hat immer die gleichen Zugriffsrechte. Ich möchte aber schnell zusammenarbeiten können. Und natürlich auch außerhalb des Unternehmens, also mit externen Agenturen zusammenarbeiten. Ich will dort nicht per E-Mail Binärdaten oder Assets austauschen oder auch nicht auf deinen FTP-Server hochladen. Das heißt, wir lösen die Challenges dieser Marketingunternehmen, indem wir den komplexen Produkt-Content managen, indem wir die Marken managen und indem wir effizient zusammenarbeiten, vor allem auch mit Creatives. Und das Ganze in unterschiedlichste Channels zu verteilen, auf Brandportale, Webseiten und so weiter. Nachdem wir jetzt nicht so viel Zeit haben, alle Funktionen herzuzeigen, möchte ich ganz kurz so einen Screenshot von unserem Produkt, von dem Content-Bereich zeigen. Im Hintergrund müsst ihr euch jetzt vorstellen, dass da natürlich Strukturmöglichkeiten drinnen sind, um die Assets in eine hierarchische Form zu bringen. Also Baumstrukturen sind da ganz typisch anzuwenden und mit dieser Asset-Liste kann man jetzt diese Dateien, diese Assets suchen, filtern dann auch und so weit einschränken, dass ich dann den Content finde, den ich brauche. Und auf der rechten Seite habe ich dann ein kontextsensitives Menü, das mir je nach Selektion die Informationen zu diesen Assets zeigt. Das können jetzt, so wie man hier sieht, irgendwelche allgemeinen Informationen sein und dann gibt es einen Tab, der heißt zum Beispiel Metadaten und da stecken dann eigentlich unsere komplexen Metadaten dahinter. Da ist das Wichtige zu verstehen, dass die Kunden selbst eigentlich dieses Datenmodell aufbauen müssen, mit unserer Hilfe natürlich, weil das eben unterschiedlichster Content sein kann oder unterschiedlichste Metadaten sein können, von normalen Textfeldern bis hin zu Produktreferenzen, die wieder auf andere Strukturen zeigen. Also da lässt sich sehr komplexe Metadatenstruktur aufbauen. Und das zweite Produkt, also dieser Workbereich, da sieht man jetzt unser neuestes Feature, das nennt sich Taskboard oder Flowboard, wo ich jetzt schauen kann, dass ich mit dem Content-Driven Ansatz Aufgaben verteile im Unternehmen und natürlich auch extern, indem ich eine Art Kanban-artige Ansicht habe, wo ich mir Spalten konfigurieren kann. Ich kann festlegen, wer hat in dieser Spalte Berechtigungen, wer soll da was machen, wie komme ich von einer Spalte in eine andere Spalte, um eine Transition durchführen zu können. Und so lässt sich sehr userfreundlich ein komplexer Workflow abbilden und die Zusammenarbeit untereinander koordinieren. Ja, dann kurz ein paar Fakten zu Celum selbst. Vor 20 Jahren in Linz gegründet. Wir freuen uns bald den 1000. Kunden begrüßen zu dürfen. Wir sind insgesamt ungefähr 100 Leute im Unternehmen. Wir haben einen Dev-Standort hier in Linz, im Headquarter natürlich, und in Wien. In Wien befindet sich auch unsere Designabteilung und Marketing. Und wir haben natürlich Sales-Standorte in Deutschland auch. Und was vielleicht in dieser Größe als Firma noch speziell ist, wir sind nicht Venture Capital funded und nur durch unseren Eigentümer geführt und daher unabhängig. Ja, von den Technologien, wir setzen auf Java, aktuell Version 11.12 im Einsatz, und Spring begleitet uns eigentlich auch seit Anfang der Spring-Zeitrechnung. Das Produkt hat ja sozusagen 2003 ungefähr gestartet. Vorher war die Firma Celum ja ein Dienstleister für die Föst, und dann hat sich 2003 ungefähr daraus die Idee entwickelt, ein Produkt zu bauen, und das ist auch ziemlich genau der gleiche Zeitpunkt, wie Spring angefangen hat. Also ich glaube 2001 wurde es gestartet und der Jürgen Höller ist dann 2003 dazugekommen. Das heißt, es ist nach wie vor bei uns sehr stark verankert. Unsere Frontends sind in Angular und die Cloud-Applikationen sind mit Docker und Kubernetes orchestriert. Und ja, in unseren Technologie-Stack, schön langsam, kommen auch neue Kandidaten dazu, so wie Keras, TensorFlow und Python, die sich langsam hier in unseren Technologie-Stack einschleichen, nachdem wir in Zukunft auch auf AI-Services oder eigene AI-Anwendungen bauen werden. Ja, wie schaut es von der Infrastruktur aus? Wir sind in der Microsoft Azure Cloud, benutzen dort zahlreiche Managed Services von Datenbanken wie Cosmos DB, Blob Storage natürlich und auch das gemanagte Azure Kubernetes Service. Und da bietet es sich natürlich auch an, mit Azure DevOps zu arbeiten. Das heißt, dort liegen unsere Git-Repositories. Wir arbeiten da mit Pipelines und mit Artifacts, um hier eigentlich sehr, sehr nahtlos mit den Services zu integrieren. Ja, natürlich kommt der Jenkins auch noch immer bei uns vor, und ja, um das Ganze mit agilen Prozessen zu unterstützen, setzen wir auf Jira und Confluence. Und jetzt möchte ich nur kurz erklären, wie denn unsere Kunden so mit unseren Produkten arbeiten, und dafür habe ich den Kunden Klaas ausgewählt. Es ist wahrscheinlich sicher schon jedem mal passiert, dass er so einen hellgrünen Mähdrescher auf der Landstraße vor sich hatte oder zumindest im Feld stehen gesehen hat. Und Klaas hat 300 Produkttypen, die in unserer Software verwaltet werden. Das heißt, angefangen von Mähdrescher, Traktoren, irgendwelchen Landmaschinen, hinterlegen dort die Informationen zu diesen Produkten, und das ergibt dann bei uns im System ungefähr 200.000 Assets, mit denen da gearbeitet wird. Klaas ist seit 10 Jahren unser Kunde und setzt eigentlich die gesamte Produktpalette, die Celum hat, ein. Das heißt, bei Klaas, das wird sozusagen im Feld eingesetzt und bei Klaas wahrscheinlich sogar auf dem Feld. Das heißt, die Fotografen, die dort vor Ort sind, die Fotoshootings machen von diesen Geräten, laden die Bilder direkt in unser System rauf. In der Zentrale bei Klaas werden diese Bilder sofort gesichtet. Es wird entschieden, mit welchen Bildern geht man weiter, mit welchen Bildern, welche werden aussortiert. Und auch mit unserer Unterstützung durch den Work-Arbeitsbereich geht Glas sozusagen so weit, dass es die externen Agenturen einbindet, das heißt einen Raum erstellt, einen Space erstellt, wo die Files geshared werden, mit denen dann weiter bearbeitet wird. Das heißt, die Agenturen machen dann Photoshop und Bling Bling, damit das Ganze schön ausschaut. Und wenn dieser Content wieder zurück in das DAM, also ins Digital Asset Management Produkt kommt, dann kann dort über automatisierte Ausleitungen das weiterverteilt werden. Das heißt, bei Glas reicht es durch Setzen von Checkboxes, von Metadaten, dass dann automatische Ausleitungen passieren. Die Assets landen auf dem Webshop, landen im Presseportal, im Download Center und so weiter. Ja, und dann haben wir noch unseren amerikanischen Kunden oder einen unserer amerikanischen Kunden, 3M. Die selber bestehen eigentlich aus oder verwalten 230 Marken. Das sind so 50.000, 60.000 Produkte, die verwalten. Das macht bei uns im System 1,6 Millionen Assets aus. Auf die haben 20.000 Benutzer Zugriff und 3M sorgt dafür, dass die Produktbilder aktuell zur Verfügung stehen. Das heißt für neue Produktlaunches, für Updates von Marketingmaterial zu bestehenden Produkten wird unsere Software eingesetzt. Das heißt, es werden Rechte, Nutzungshinweise verwaltet und auch Beschreibungen von diesen Produkten. Und 3M verwaltet die in 130 verschiedenen Sprachen. Also das ist schon ein gewisses Metadatenmanagement dahinter. Ja, und zu guter Letzt noch einen österreichischen Kunden, die Firma Rosenbauer. Auch hier setzt unsere Software als zentrale Quelle für Medien ein, für die Verwaltung der Medienrechte. Bei Rosenbauer ist es so, die produzieren nicht nur selbst sehr viel Content, die haben auch noch die Challenge, dass ihre Kunden und Partner sehr viel Content generieren oder auch in Social-Media-Kanälen produzieren Personen Content, der für Rosenbauer Marketing relevant ist. Zum Beispiel beim Flughafen Düsseldorf, glaube ich, war es, wie die 5 Panther, die sie bestellt haben, bekommen haben. Die haben eigene Image-Videos gedreht. Also der Flughafen selber, wie toll jetzt sozusagen diese Anschaffung war, wie sicher jetzt der Flughafen ist. Und dieses Video, das möchte natürlich Rosenbauer selbst auch für Marketingzwecke nutzen können und das im eigenen System verwalten. Da gibt es auch Integrationen in Microsoft SharePoint, ungefähr 200.000 Assets im System und sind auch schon seit 14 Jahren unser Kunde. Ja, und wir haben natürlich viele Kunden aus unterschiedlichsten Bereichen, also es gibt eigentlich keine bestimmte Branche, in der wir vertreten sind und es findet wahrscheinlich jetzt jeder irgendein Logo, das er schon mal gesehen hat, wo die Celum einsetzen. Somit wäre ich am Ende und wir könnten uns den nächsten Vortrag anhören.
Good. So, hello, my name is Lukas Goski and I'm working at Celum for over a year right now. I'm from Vienna branch office and I came here together today together with my colleague Daniel. So basically we'll do this presentation in 2 parts. At the beginning I will just tell some theory and then Daniel will overtake and show some examples. So today we want to talk about the behavior-driven development that is used actually here at Celum and which helps us produce a good quality software. So what's on the plan? Small agenda. So first, what is the BDD? Then I will talk a little bit about the development process, then about the common language for the business and for the technicians. And at last point, there will be a small BDD showcase. So let's start with some theory. What is BDD? So basically it's a process designed to help deliver software by improving communication between the business and engineers, and it closes the gap between those two worlds. So in the BDD, all parties are describing the behavior from its stakeholders' perspective, and BDD ensures that the development remains focused all the time on delivering what business needs while meeting the requirements of end user. It is achieved by usage of some common language which both parties can understand, and by encouraging the collaboration across roles to find a common understanding of the problem to be solved. The BDD differentiates a little bit from the test-driven development, and basically it fixes the test-driven development in one way, because it's stated there, what you can read, that the test-driven development ensures that you build the software correctly, not that the correct software was built. So with the BDD, we try to ensure that not only the correctly working software is being built, but also that the software is being built from the business perspective and in the right way, and we achieve what the customer actually needs. So what are the benefits of the BDD? So first of all the development work can be traced back to the business objectives, having user stories, acceptance criteria, BDD scenarios, and so on, can give you a really good transparency in what was achieved, and ensures that only the necessary software is being built. Then the software developed meets the user needs, and this is kind of important because satisfied users means that the business is good. The next benefit is the efficient prioritization. So basically, it's easier to identify business critical features and make sure that those features are delivered first. All parties share also the common understanding of the project and can be involved and should be involved from the beginning in all the communication. Shared language ensures also that everyone has a good visibility of the project's progression. Then the next benefit is that the resulting software design matches the existing and supports the upcoming business needs. So you can better prepare for the future. With the BDD, we can improve the code and project quality, and we reduce maintenance costs. So therefore, we are minimizing also the project risks. So the tooling, there are many tools that help you to implement the BDD in your teams. Here at Celum, we are using Cucumber for this purpose. It's an open source tool which supports and executes the specifications written in the plain language. It produces also the reports that indicates if the software behaves according to the specifications or not. So with Cucumber, we are reducing the time spent to keep requirement specifications, tests, and documentation in sync, because in the Cucumber, all those three things are one document basically, and this is the only source of truth for everyone in the team. Cucumber is compatible with all major software platforms, so you can use it not only with Java, but also with C#, JavaScript, Ruby, and so on. And also has pretty good integration with all the most popular testing libraries. So here at Celum, we are using it together mostly with Java and Spring, and with the support of IntelliJ, which also provides some good plugins. Yeah, basically the whole stack makes our lives much easier. So the development process, this one is pretty easy and straightforward. It's an iterative process consisting of 5 easy steps. first one is to describe the behavior. So as mentioned before, it's important that a lot of parties are taking part of it. So not only the technicians, but also the QA and the business. So all the parties should collaborate to produce this description of the behavior. The second step is to document that behavior in a way that it can be automated and implement those step definitions. Usually this step is the most tricky part because you have to find the correct abstraction level and make sure that the steps may be reusable and so on. So usually this second step takes the most of the time. And it's pretty important so that the maintenance later on is not so big. The third step is run and fail. So basically, if you do not have any implementation, then there is no code that should provide the correct output. The fourth step is write the code to make the step pass. So actually, this is where we are writing the business logic. And when everything goes good, we go to the fifth step when everything is green, and we can say that the feature is complete. So now maybe something about the common language. I just provided here a small sample. Later on with the BDD showcase, you will go more details into it, how the Gherkin syntax looks like and what it can do. And this will be shown by Daniel. So basically here is, as I said, an example of some Gherkin syntax. We can identify some keywords there, like the feature, background, given, when, then, and so on. So the feature keyword is used to provide some high-level description of the software behavior and to group the related scenarios together. So this is pretty important to describe it correctly, and so that whoever will read it can immediately see what exactly will be tested here. So as we see in this sample, the feature is get cash from ATM. It could be also, for example, check the balance in the ATM. Then the feature consists of the scenarios. So scenarios explain how a given feature should behave in different situations with different input parameters. Here we see two scenarios. One is like success scenario, so the getting cash from ATM was successful, and the second scenario is that there was not enough money in the ATM machine. The third scenario could be, for example, that the person itself didn't have enough money on his account, and so on and so on. So we can here identify some edge cases and write them down. So it makes easier also for some other people to see how the software behaves and what is tested and what is covered by the software. Then inside of the scenarios we see keywords like given. So given describes the initial context for the example. If we look at the top, there's like, so the initial context for our scenarios are the ATM has 1,000 euros, the user John is authenticated, and the user's account has 5,000 euros. Then the when keyword describes the action that the actor in the system or stakeholder performs. So basically we can see that there is actually one action with two different input parameters. The user asks the ATM for, in one scenario, 500 euros, and in the second scenario for 1,500 euros. In the third scenario, it could be 6,000 euros to hit this another edge case. The then keyword describes the expected outcome of the action. So we can see that in the first scenario that was successful, ATM should have less money, user account should have less money, and the ATM itself should provide some money to the person. And here you have noticed that we have a background keyword. So sometimes it happens that some steps are being repeated in all the scenarios. So that can be an indication that those steps are actually not really relevant for the behavior itself. And in such case, we can move them exactly to the background, and in that case, to group them in the background keyword. So that helps actually in readability of the whole feature file and the scenarios, not to make them too verbose. Good. And now let's move to the showcase.
So, hello everyone, I am Daniel, and I will be showing the actual live example. Let's see, how do I move this to the other screen, like so. So, show of hands quickly, who has ever heard of Rick and Morty? Okay, we have a couple. So this example was actually inspired by them, and specifically Picoric. And the scenario here is about characters in this cartoon. So we have a Spring application which basically at this point has nothing working. It's very nice, it's booting up, and if we run it, then it does the nothing. And we want to create this feature for it. So we want to, very basic business scenario, we want to make CRUD operations on characters. So maybe let's start on the first one. So how would I go about this one? With this syntax, I would say given Rick does not exist when Rick is created, then Rick should be stored. Something like this. So, really very basic scenario, but is it really good? Because it's very specific, so it's specific to Rick. But let's say that we want to be a bit more generic, and we want to say that Rick is now a parameter of this thing. So let's make him a parameter everywhere. And let's say that we don't care about that part. So, next step, we want to generate something out of these things, because in itself it will not run. So if I try to run now the feature, it should fail. Building. And it failed. So, next thing, we want to, okay, maybe not. We want to generate the steps, and we want to use Java for it, and it really doesn't matter what we call this file, but what is important, what is inside of it. So now we got some code that if I run this again, since these steps do nothing still, will now pass. So let's run it again. And okay, something I'm missing. application. Okay. So it says I am still missing something. But let's jump ahead a little bit and let's say that I actually did write all of these. Yes? Font size. Okay, let's see if I can. Yes, I can. Is it better? Okay. So let's jump ahead a little bit and let's say that business did already define all of these steps for us because they were nice. And let's rename this one to feature. And let's take a peek. So at this point, we have a bit less generic implementation of these steps. Font size, yes, sorry. So a bit less generic one. And it kind of shows what type of parameter inputs we can put in here. So let's say that I actually put something in this implementation. Why is it called user? So now I have some implementation for these steps, and the trick is that I actually need to uncomment these. So in a second, no, unfortunately, the keyboard is German, which does not really agree with me, but sorry for taking so much time for it. But now we should have a complete implementation for these steps. And I say should because apparently there are some things missing. Okay, so let's create this step definition. And at this point, actually, IntelliJ with the integration realizes that I already have some step definition class. So it's nice enough to offer for us to put this in this file. So let's say that, okay, I really do want this in my file. And then I will say, okay, so this is the name of my character. And I want this name to not exist. If it doesn't exist, it's safe to create it. So we will try to create it. And then as a last step, we just check if this user actually exists. Let's also create it here. So far, so good. So what do we need to do in order to make this pass from the coding perspective? So obviously, let's see at this point, somehow I need to be able to check if this user is actually there. So for that, I think very first step is let's maybe create an entity that will hold this data. So name, and let's put a role on it, just so it's not one field. And then we need some repository for this character. So let's make a repository. Very straightforward, just one repository, and we will search for this character's name. So in this step definition, I will say that at this point, character repository should be fine, which it isn't, although it's imported. So what's the beef in here? Okay, I need to stop. Is it running maybe? No. Okay, also not trying. Should be fine. So, does not exist. Ooh. Okay, I might have to ask a little bit of help with the German keyboard. Could you, please? Yep, thank you. It's on English now. No. Then you might have to stay. So let's say it should just fail in this case, if it exists. Okay, so we did that. Next step, we say that we should actually create it. So for this one, we want to call some endpoint, like some controller, with a post, create this character, and be happy about it. So we probably need a controller. Also pretty straightforward. Aha, okay, I now realize what the problem is. I don't have Lombok. No? Lombok. I do have it. Okay. So, plugins. Lombok. Install. Accept. And be back in a sec. Okay, yes, please do it. Now it's much better. So now we have required argument constructor. No more red. So now we can actually call this endpoint. And the last step is that we just want to check if this actually exists at this point. So no, please go inside. Yeah? Yes, sorry. Okay, so character should be created. So we check if this character was created, then the returned value should be successful and it should be also in the database. Let's try to run it. Okay, so does not exist. I think I messed it up with these two steps. So let's try it again. And now it passes. So, couple of things to note about the Gherkin syntax. So, what type of parameters can we put in these steps? Let's start with the most basic ones. So, here we have just a string as a parameter. That's, I would say, the most easy and common, and also some numbers. So if we check out the definition of these steps, here we see that in the step definition we can just write any primitive type of Java, and it will be automatically converted to that type for this step definition. So this is true for strings, numbers, booleans, yeah, stuff like that. So here we see something a bit different, and this one actually has not one but two input data, and it's not one scenario but two. So first we have one input, and then we have the second one, and we can reference these by the header of this table. So here we want name, here we want role, and you just put between these two nice tags, and it will know that I want to reference this one and I want to reference this one later on. So this gives us some flexibility to define a bit more data for the same scenario, and this way you can actually put all your edge cases in one step. So if you know that, for example, the character should have at least one character in their name, or at maximum 100 or something, then you could put those edge cases in here and see if it still works. So let's move on to the next part. Let's say now we want to put these characters in some episodes, just for the sake of having some relations between these entities. So in that case, we would define some episode which will have a title, which will have a plot, and it will have some characters in it. And we want these guys to have their own feature. So let's rename this one to dot feature. And yeah, so second guy. So we want to define basically some very easy scenarios for this one also. It's more for showing different types of inputs. And here you can see that this table is actually not on the end as example, and it's not a scenario outline, which means that this is actually one input parameter for this step. And the way it's handled is as follows. So we are actually passing a whole data table for this step, and you can work with all of the data within the step. So it won't be invoked as many times as many lines you have in the table. It will just give you the whole thing at once. And actually that's what we want, because as a preparation for the story, we want to create all of these characters. That's the idea. So if I go back to the definition, here you can see that I am basically just calling the methods that are already there for creating the characters in the previous scenario, because I already have please create me a user, and also please fetch me some user. So in this one, we're just calling some additional things. Blah, 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 blah. Where are we? Okay, going back. Yep. So create character and ensure that this character was actually created. And then we want to create the actual story. So we give it a title, we give it some plot, which we defined in the episode. So it has to have a title, it has to have a plot, and it has to have some characters. We define those things, and we say that, okay, now please create this thing for me. And again, episode. Let's say that we implement it. And yeah, there is one crucial thing that I actually didn't mention yet. We can share some data between the steps. Otherwise, this one would not work. For example, since I just created these users, but I'm not defining these anyway for this step. And the input for this step is just the title and the plot. But we also want the characters. So what we do is create worlds. And in this world, we define what we want to share. In this case, it's a set of characters. So we have to ensure that the preparation step, what is defined here, actually puts those users that we created, or characters we created, inside this world. So in the next step, I can actually reference that world and just take them out and put them in my request. And that looks as follows. So I have the world, I get the characters, I add the character, and in the next step, when I actually want to use it, then I just use the same character world, get characters, add it to the DTO, and put it in the request. And that should do it. So as the last step, again, we just check if it was created. So, okay, it's defined, good, but we actually need to implement it. So again, by the magic of presentation, here we have the repository, and now we actually have some controller for it. Again, pretty straightforward, not doing too much, so just saving it in the repository and finding it by ID. Let's run this one. And it passes. So, if you can remember, Lukáš mentioned that the way that, and if I just go back to this one, yep, it's this one. So, the way that this whole development process should look like is that we first define the behavior, so we write down these steps, and then we implement, but then we run it and then we fail, but then we write some code and make it pass. So at this point, what usually happens in the real life is that we have some very high level business requirements, and in the step definition you probably don't have something as detailed as this one. So you go and define, okay, if Rick Sanchez does not exist, then this should happen. And when you start implementing it, I mean the step definition, not the code yet, then you start thinking about, okay, but how do I ensure that this guy doesn't exist? I need some repository for that, or some endpoint for that. So at this point you will start implementing this repository. So you're not really done with your step definition, but you already implemented something. And as you go on with this step definition, you will have more and more things implemented. So I would say that it's kind of in between, it's a continuation and going back and forth between the steps. And at the end, where you already have all of your steps clear at this level, so you already know that you want a table here, you want something other than that here. And you know that you need some endpoint to invoke those things. And that's basically how you get from not having anything or having a very, very high level business description of it to having your implementation. Maybe just one more interesting thing is that I mentioned that you can put, basically these are the default things that you can put in a step definition. So you can either define the primitive types, you can define some templates for it, and you can define tables or this markup, which we have here. But some things are blue, and it's not native, it's not these two, so what it is. And it turns out that you actually can create things that are custom to your needs, and you can actually register some other types. In this case, I just defined that wouldn't it be nice if we could write should not, and that should mean some boolean in your code, executing one thing or some other thing. And this way you can actually reuse this same step definition for checking if the user actually exists or it doesn't exist. Here, Morty does exist. Here, Snowball does not exist. And that's a pun, by the way, but and this is actually the same step definition. So if I go here, it's the same thing as this one. And the only difference is that I have a different condition. So for that one, we have this condition parameter, which allows the following things. And we figure out, okay, if it contains not, then we run the negative one, otherwise we run the positive one. And from this point on, you can just put this special step, if you register it, in this Cucumber registry. So you just add it to your defined things. And that point on, you can write in your step definition should not, and it means something that is custom to your needs. So I think that was most of the things I wanted to mention. Maybe some short Q&A if we have time, I don't know. Do we? Okay. So any question to Lukáš, to me, or to Rudy? René?
In case if there are no questions at the minute, there's plenty of time afterwards when you do the networking part, so feel free to ask Danielle or Lukáš in regards to behavior-driven development. Interesting features, very readable approach. And I guess now it's time for Rainer Struppeck. We're going to do a short break, 5 minutes max. Rainer's setting up his PC and presentation. Afterwards, please be back in here and we continue with Rainer's talk. Thanks.
So are we ready to go?
I guess we're ready to go.
Very good. So, thank you very much. Thank you very much for having me again here at the Technologieplauscherl. My name is Rainer Stropek, and I'm a passionate programmer. I have been using C# for many years. I don't know how many, but since the very early CTPs and technology previews and so on, and for years I've been writing code in that language. Recently, in the last years, I switched a little bit, or let's say I enhanced my coding skills a little bit by taking a look into Node.js with JavaScript, TypeScript, Go, and so on. And recently I saw that, especially in C#, Microsoft is doing a lot of work in terms of memory management. I will talk a little bit about it. And I got curious. Where does it come from? What is the idea behind it? What is this trend that I'm seeing? And I took a look at Rust. And I found very interesting concepts that I wasn't aware of as a C# or JavaScript or Go developer. So I thought I'd share my thoughts and findings of my first adventures towards Rust and my comparison in terms of memory management of C# and Rust with you. Let me start by showing you a little bit of demo code and phrasing the general problem that Rust is trying to solve. This chart shows vulnerability and patches per year, and this white line that you see here and the dark blue area on the bottom is the number of vulnerabilities and patches with regards to memory safety issues. And if you can't read it, this starts here in 2006. And we are currently at 2018, and still nothing has changed. Nothing got better. We had approximately 70% of vulnerabilities related to memory safety issues in 2006, and we have roughly around 70% of vulnerabilities regarding memory safety issues in 2018. And this is an official study and that you can read. I have the link in the slides here. It's from Microsoft, and you can think of Microsoft whatever you want, but those guys aren't all completely stupid. So just sitting down and saying, okay, tomorrow I will write C++ code that doesn't have a memory leak, that doesn't do a double free, that doesn't do a use after free, is just not enough. We are just not good enough in about compiling code in our heads. We need more support. And that's the basic problem. So let's take a look first, before we take a look at the solutions, let's take a look at some of the problems. You will now see very ugly code, so be prepared. Just an idea. We have a method here. This is C++ code. Very ugly C++ code. Maybe I have written it, I don't know. No, I came up with it just to prove the point. As you can see, we are allocating a little bit of memory here in this getData method. We are copying some code in it, and then we return the buffer. And the user, as you can see it here, the user gets this buffer here and prints it on the screen. It doesn't matter, it consumes it somehow. And what do we have? A beautiful memory leak, because nobody is responsible for freeing that memory. Of course, if you see it on a single slide, everything is clear. You look at it and you know, hey, I forgot to free it. But think about more complex applications. I'm totally aware, and I want to emphasize that. This is not C++ special. I'm totally aware of the fact that today in modern C++, you have lots and lots of functionalities to not having to write this code anymore. You have smart pointers, you have structures like vectors and strings and a lot of other things. I know, but still, I see code like that. Many people see code like that. That's a problem, and we will take a look how Rust makes it even better than makes these situations even easier to handle and detect than modern C++. Another problem. Here you can see we allocate a little bit of memory. We try to do some kind of SQL statement, for instance. Then, when executing this SQL statement, something bad happens. See it here? And we free the memory. That's fine. But unfortunately, many pages later of source code, somebody has an if statement, if something happens, we try to do a logging and we use the statement which has already been free. This is a typical use after free. And we all know we shouldn't do that because this is really a security vulnerability. Another example for use after free, and this time it might surprise you because it's C#. How can we do a use after free in C# if we have managed memory? That doesn't work. We never free memory, don't we? We have the garbage collector who cleans up after us. Well, it turns out that C# recently has learned a lot of tricks to make it more efficient in terms of memory management. And one of the tricks that C# has learned is, for instance, well, that's not recently. The recent stuff comes later. This is old stuff. Let's start with this one. I mixed up the order of the slides, sorry. This one, it's using the disposable pattern. A disposable pattern is necessary because if you have a garbage collector, you can never be sure when the garbage collector cleans up your mess after you. Therefore, you have this nice little dispose method which you can call explicitly to tell C#, hey, clean up. And therefore, I can write exactly the same code with exactly the same problem and accessing this connection, although it has already been disposed. You know what C# will do if you do something like that? Object already disposed exception. Boom, runtime error. This is exactly what we don't want to see. Another C++ stuff. We have a pointer to an integer, as you can see it here. We clean it, as you can see it here. But we also call a method called printValue. We pass in this pointer, and this method here tries to be very, very clean, and also deletes the pointer. And what we have is a double free problem. We should never do that, because we have an undefined state in C++ memory manager, and therefore bad things can happen. That's a security vulnerability. We don't want to be able to do things like that. Now this one is the new one. I mixed that one up. Again, a double free problem in C#, which is absolutely not obvious. This is a recent one, because the thing that I would like to point your attention to is this array pool here. Why is there an array pool? It turns out that C# isn't very good in handling large buffers, large arrays, for instance. If you allocate a lot of large arrays, they are not handled in the usual way as C# usually handles memory. It turns out C# becomes a little bit unstable or not that fine to handle when you allocate a lot of arrays. You should really reuse arrays. And array pool is a way to ask C# to give you an array and to reuse it later on. So you can ask the array pool for an array in a certain size. It will give you this array. You can give it back. And if somebody else asks for another large array, this piece of code will get a reused version of this array, so you don't need to allocate a new one. This releases the pressure on garbage collector. And guess what? It's pretty easy to produce a double free problem here. Because if you do something like this, you have a return of this array here, and you have a return of this array at the same time. And you must not do that. A double free problem directly here in a managed language using the array pool. Okay, enough problems. Let's take a look at solutions. First, I would like to introduce you to some new concepts that have recently been added to C#, version 7 and version 8. First, C# tries to solve a lot of the problems that we discussed before by introducing memory management, managed memory, and a garbage collector. You do not need to explicitly free memory. That's good. It solves a lot of problems, not all, as we have seen, but it solves a lot of problems. The big problems that C# introduces with that is performance. The garbage collector is not a zero-cost abstraction. That means you pay the price with performance. You never know when the garbage collector cleans up. You will never get the most performant code that you could write without this abstraction, because the garbage collector is always guiding you, and you don't have the control that you would like to have. But C# learned, as I said, a bunch of new tricks to really solve that problem on a very basic level. And now C# in the version 7, they added 2 new types in this regard. The first one is called span and the second one is called memory. And essentially what these 2 types do is they add an API for accessing different types of memory, especially unmanaged memory and managed memory, through the same API. And with this, if you really need in C# to access unmanaged memory, or with span even memory that lives on the stack, you can just work with span of t and memory of t and have an abstraction that is independent of whether your bytes live in managed memory or unmanaged memory. You can write, for instance, a parse method which turns a string into an integer, and you make it consume a span or a memory, and suddenly you have a method which can operate on unmanaged memory and managed memory without having to write it in a duplicate way. That's very important. That's a new way of abstraction that Microsoft introduced here. In addition to that, Microsoft issued a bunch of rules that you have to follow if you work with memory, because it turns out dealing with these classes can lead to a lot of problems, to many of the problems that we try to get rid of with the garbage collector. Let's take a look at these rules. The first one is the ownership rule. Only one owner is responsible for lifetime management, including destroying the buffer. You always have to be very clear who is the owner of a certain piece of memory. And now I'm not talking about a piece of memory that the garbage collector cares for. I'm talking about a piece of memory that you explicitly have to care for. For instance, unmanaged memory that you allocated because you want to be fast. All buffers have a single owner, I told you that, but you can transfer ownership. If I create a bunch of memory, unmanaged memory, I can pass the ownership on to another function, and then this function is now responsible for cleaning up the memory. If this memory isn't cleaned up, it's their fault, not my fault, okay? If I transfer the ownership, and that's the third one, I must not access the memory anymore. If I give it to somebody else and I say, it's now yours, do whatever you want with it, this guy can immediately free it, so I am not allowed to access it anymore. That's the kind of rules that were stated for ownership. However, there can be multiple consumers of some memory. It can be a read-only or a write-only. There is read-only memory and memory of t and so on. And as I told you, a single piece of memory can have multiple consumers. You have to care for synchronizing that. Synchronizing readers is simple. Everybody can read at the same time. Synchronizing writers, we all know it's hard. Finally, we can also speak of a kind of lease. Lease means that we can give somebody a piece of memory for a certain amount of time, and if the lease times out, the receiver of the lease is no longer allowed to access the memory. With that, we can apply the rules of the garbage collector to the lease, and when the garbage collector cleans up the lease, or the lease gets out of scope, I'm no longer allowed to access memory, something like this. Do these rules sound complicated? Well, the first one or two, maybe not. The other, well, maybe. Let's take a look at some code. Here you can see, first line here, let's draw here so we have it on the video too. The first line that you see here is a usual piece of memory. We say memory of bytes, it's a new byte, it's managed by the garbage collector, it's really trivial, we never have to free it, nothing bad can happen. But the beautiful thing here is that we have here the possibility to allocate memory from unmanaged memory, and sometimes we need that if we want to be fast, if we want to interop with some low-level stuff. And the interesting piece of code is that one. See that one? We now can use the memory abstraction to access unmanaged memory. And we have a memory of byte here, and we have a memory of byte here, so it's possible for us now to write code, especially here, this method, to do something with a span, without caring whether do something with span operates on managed or unmanaged memory. C# offers an abstraction that works with unmanaged memory with managed memory, and to be more specific, we are not going into details, span can even work on arrays that live on the stack. So I can pass in a pointer to a memory on the stack and still my method works. You know why Microsoft did that? Because they wanted to speed up especially ASP.NET and things like that. It turns out when you get some memory from a low-level network driver, it's not managed memory. And what did they do until now to write a web server in C#? They copied the unmanaged memory into managed memory. And what did they do then? They applied methods like .substring and things like that. And a .substring method, string is immutable, copies the code, copies the string. And the string is copied and copied and copied. It works perfectly fine. But copying the memory over and over and over again takes time. And the garbage collector has a lot of pressure on it. And that destroys our performance. And with C#7, these abstractions make it possible to keep the memory in unmanaged space. It's fine. We now have abstractions that can work directly on this unmanaged memory, and that is pretty well. That is pretty nice, as long as we follow the guidelines that I told you before, because somebody has to free this memory, otherwise we are in deep trouble. Good. This is another API. I will quickly go through it. Can you remember what I told you about the array pool? We shouldn't allocate memory again and again and again. We should reuse memory to reduce the pressure on the garbage collector and keep our memory safe and so on. It's also possible to define a memory pool, which is more a lower level data structure. And here you see this memory ownership. I can say, hey, memory pool, please give me 100 bytes. And if I get it, I am now the owner. You see that one? I am the owner. And I'm on the same time, I am the consumer. And now we write a little bit of code and apply the rules that I told you before. What we can do, as you can see it here, we can call a method and pass in some memory. And with that, we are still the owners, but somebody else is now allowed to consume our memory that we have rented. Get the idea? That's the idea of consumers and owners. Now if we write another method which takes in the iMemory owner interface, we really pass on the ownership. Now we are not allowed to free this memory. We are not allowed to give it back. Because we passed on the ownership, this guy here, this guy is now responsible for freeing the memory. We handed over the ownership. That's this set of rules that I told you before applied in a piece of code. Okay? This is pretty new C#, and yeah, you can find this code now over and over in more lower level algorithms. So what is C#'s solution to our memory management problem? And then we'll invest the rest of the, 20-25 minutes or so in Rust. Okay? C# solves this problem by offering a bunch of helper classes and abstractions on a framework level, on a library level. You get interfaces, you get classes, and very important, you get rules. Follow the rules and everything is fine. For me, this is not perfectly okay, but because it just sounds like a little bit of better C++. Just, as programmers, we have to sit down and write better code. Every day we have to stand up and say, today I will write better code that has no memory vulnerabilities in it. And we have seen in the first slide that this simply is not enough. It's not enough. We are not good enough as humans in compiling code and making sure everything is fine. Entering Rust. Rust, one very important concept of Rust is that you are going to hate it because you get so many compiler errors. But the good thing is, if your program compiles, there is a very high chance that it really works. And that's good. So the idea of Rust, and from now on we will take a look at Rust code, not a little bit C# to make, again, the comparison, but most Rust code. In Rust, all these things like classes and interfaces and abstractions and rules, they are gone. They implemented all these memory concepts, these protections in the language. not in the framework. And the compiler has the responsibility to check these things at compile time. You do not need to follow rules to make sure your code is safe at runtime, because these rules are enforced at compile time. If you mess something up, you will get a compiler error, not a runtime error. That's the whole idea of Rust in terms of memory management. Now let's take a look how that looks like. In Rust, every variable, every value that is assigned to a variable, let's put it that way, has a clear ownership. And this ownership, as I told you, is now defined in the compiler, in the language. There can only be one owner. And if you pass on the ownership to somebody else, you cannot use the variable anymore. Can you remember what I told you about C#? That you can pass over this I memory ownership and you must not free it? Well, you should not free it, but you can. In Rust, you can. When the owner, the variable, goes out of scope, the value will automatically be dropped and memory will be freed. Rust will make sure of that. There is no garbage collector. If your variable goes out of scope and you are owner, then the memory is going to be freed. You don't need to free it manually. Now let's take a look at a little bit of code. First Rust code for today. I hope you can read it in the back. Is that okay somehow? If it's too small, please let me know. I can zoom in. I have a zooming tool installed on my laptop. Now, this is the main function as you can see it here, and I'm creating a vector of integers. This is just a macro, so this means macro creates a vector. A vector lives on the heap, and we have a memory called, we have a variable called numbers, and this variable numbers is just a pointer to the heap, okay? And then we just print the numbers. It would print square brackets 1, 2, 3, 5, 8. This would be the output on the screen. Now what we can do is we can assign, let's draw here on the screen, look at this line here. We can assign numbers to other numbers. And guess what? We passed the ownership. Let me show you that again. Here, the variable is numbers. Now, we pass the ownership to other numbers. If we would try to access numbers anywhere from here down, we will get a compiler error. Rust will immediately say, no, you are no longer owner. Numbers is dead. You don't have it anymore. It's now called other numbers. Other numbers, of course, can be used. No problem. So as I told you, if we try that one here, that one, it will not compile. It will not only crash at runtime, well, it cannot crash at runtime because there is no runtime. Okay? By the way, if you download my slides, and I will happily share them with you, I will share them through Twitter or I don't know, anywhere. If you can't find it, just send me a note. You will find here, down there, links. Nearly every sample has been, I copied the sample onto read execute print loop REPL.it. You can just click on it, you get the code immediately, and you can play with it immediately, okay? Just try the code and make sure that it really doesn't compile. However, what we can do is we can clone, as you can see it here, okay? Here, I clone the other numbers. And therefore, because I clone it, I can still access cloned numbers and other numbers. That's fine. We can still do that. Okay? But ownership, clearly defined. Next step. Ownerships and functions. Again, we have a vector. I don't need to describe a vector anymore. You already know that. And as you can see here, we have now a consume function. Please note that one. And this consume function receives a vector. Rust, in this case, or generally, only knows whole by value. Pointers are just another value, okay? In this case, we are passing in the vector, and as I told you, the vector lives on the heap, so we are just passing the pointer to the vector into this function. But as you can see here, maybe you followed the arrow here, by calling this method, we passed ownership from our main function to the consume function. Now, if numbers gets out of scope, here, the vector is automatically freed because now our consume function is the owner of the vector. Can we still try to access the numbers up here? Oh, sorry. Can we still try to access the numbers up here? No, that's no longer possible. The same is true with a function that produces something. Take a look at the second function here. Maybe it's hard to read from the back. Let me zoom in a little bit for you. You can see this produces a vector. It produces a vector by filling it with some numbers. Very simple. By the way, this is the syntax as you can return values from Rust. There is no return statement. You just put an expression as the last statement in your function, and that does mean return numbers. Okay? This is a producer. Now this producer is currently owner of this vector. But by returning this vector, the ownership goes back to the main method, and now the produced numbers are owned by main, and they are going to be freed when we access the main method, because the owner is now the main method. Understand what I mean? Transfer of ownership between different functions. A consumer does not absolutely need to take ownership. We couldn't write meaningful applications if we always pass on ownership. So there must be something else. And this is called references and borrowing, especially borrowing. Let me show you what I mean. Again, our good friend, vector. This vector is printed, as you can see here, just on the screen. Nothing special. But now we have a consumer, and please note that this consumer here gets a reference to the vector. Not the ownership, but just a reference. And with this, we, the main method, keep the ownership, and we only borrow the vector to the function. So now the function consume can access the numbers, but only in a read-only style. It is a read-only borrow. It is not possible. I will zoom in a little bit so that you can see it a little bit better. This is not possible because borrowing a reference does not mean that you can write to this variable. It does just mean that you can consume it, that you can just read from it. So pushing something onto the vector isn't possible. And it will not give you a runtime error, a compile time error. Okay? Good. And these compile time errors, by the way, are pretty nice. Let me finish this slide and then we can immediately take on your question, okay? Now here you see another option. What if the consumer wants to write to this variable? That's possible too. In that case, we have to specify that this is a mutable reference. Now it still is just a borrow, but it is a mutable borrow, okay? So somebody can write to it. And the important thing is that if I borrow something to somebody in a mutable way, I cannot borrow this thing at the same time to somebody else in a read-only or also mutable way. That's not possible. Rust will make sure that this cannot happen. Okay? Question?
So how does compile know to push the write operation?
Because deep down, somewhere, somebody has to write to this memory. And it figures out automatically that push writes to this data structure. And you also, for implementing low-level data structures, you also have some additional, more advanced things, like, I don't know, ref counting, pointers, smart pointers, and so on, unsafe blocks, and so on. You can always press the exit button. You can always take the red pill instead of the blue pill and do whatever you want. So it is possible to let Rust know that this is really a writing function. This would be out of scope of this talk. We don't have enough time, and maybe I am not well enough educated in terms of Rust already to answer it to the full extent. But for now, let's just assume Rust knows. Okay? Let me show you an example where borrowing saves us a lot of trouble. You see, this is a so-called, I call it broken iterator. Maybe you have that in other languages. This does the following. It's an asynchronous algorithm, okay? Let's start from here. We have, let's see here, we have an asynchronous function. You see that here? So we have a vector inside of an async function. Then I do the following. I call down here another async function, sum, and this just iterates over the vector and calculates the sum. And just to make things a little bit more interesting, see, I'm waiting for a little bit of time during iterating through the vector. Maybe we access the database or some files or do some complex mathematical operations, whatever. It takes a while we are stepping through this vector element by element. And now I will do something which is very, very bad. While at the same time my iterator is walking through the vector, I am manipulating it in the main function. So now we have a problem. The iterator would be broken. It's no longer possible to continue walking through the vector because the vector has changed, and therefore very bad things will happen. And this is not possible in Rust. Why is it not possible? Because here we pass in a borrow, and here we also pass a borrow, but this is a mutable borrow, and this down here is a read-only borrow. And what did I tell you? It's not possible to have a mutable borrow and a read-only borrow at the same time. Compile time error. This code doesn't compile. Get it? Compare that with C#. This is C# code, very old C#. I have a list, something similar to a vector. I have an asynchronous method, exactly as in Rust here. I go through this enumerator, here you see it, with a for each loop, also waiting a little bit while iterating through this list. And at the same time, please note this one. Nope, I have to go one. Come on. Ah, now it works. At the same time, I'm adding a number while iterating through the list of numbers, and guess what? C# is perfectly fine with that. It will allow you to add something to the collection, and it will crash at runtime. So Rust protects you from this mistake. Okay? That's the idea of borrowing. You might ask yourself, okay, if I do async programming, how should I communicate between different threads? And Rust for that has multiple options, and one of the most useful options are channels. There is in the base class library of Rust a so-called channel, and in this case I'm creating a channel of type integer, and what I get back is a tuple, two values, sender and receiver. Sender, I can use it to send something in the channel. Receiver, I can use something to read from the channel. Then I can create a receiver, very simple loop. As you can see it here, I'm just looping over the receiver. Let me quickly show you a little bit of this Rust code, because it's at least for me, when I was starting new with Rust, it was a little bit strange. What you see here is a loop, of course, and then we use the match statement. The match statement here calls the receive function. And this receive function can give back either, okay, everything is fine, I have a result for you, or it gives you back error, something bad happens. Here is some error information. And in Rust, something like this is an enumeration. That's a little bit strange. An enumeration in Rust can have parameters. Every enumeration value can bring some parameters with it. So receive returns an enumeration consisting of OK and error. OK has some payload bringing it with, and error has some payload bringing it with. So therefore, this match statement is really mentioning all different enumeration values and consuming the parameter, the payload of the enumeration value, and in this case I'm just printing. So this is the receiver, pretty straightforward code once you understand what enumerations and the match statement is in Rust. And now let's see how we can produce some values in a different thread. Again, a little bit of Rust syntax here. This is a lambda function in Rust. Between the two pipe symbols, we can write some parameters like we typically do in braces, and afterwards we would have a fat arrow. So in other languages, this would be something like this. This would be like how it would look like in C#. Okay? It's just the syntax. But the interesting thing, what we have here, is this move here. Move means that the closure variables, the captured variables, especially the sender, are copied, are now owned by the child thread. So the ownership of the sender is transferred into the child thread. So now the child thread can use the sender of the channel to send information. And now we have what we wanted. We have an asynchronous process up here sending some data, and we have another thread in a loop consuming this data without having any problems with borrowings or shared memory or semaphores and data races and all this stuff. The channel is a safe way of communication between one thread and the other thread. And the ownership principles and so on, they still apply. So what? What is the conclusion? C# has learned a lot of new tricks. They have learned that memory management, managed memory management, is a great thing. It gives you a lot of stability, but it doesn't solve all problems. Think of the broken iterator, for instance. Think of the dispose pattern, where I can free multiple times. And I can create code that is not very stable, let's put it that way. The garbage collector is, performance-wise, pretty costly. So now C# has introduced new types with which we reduce the number of times where we need to copy memory. And the results are pretty impressive. With the latest version of C#, a new JSON parser, for instance, was introduced, which is 2 to 3 times faster than the old one. The old one wasn't bad. It was a very, very good piece of software, but they didn't have the memory abstractions like memory and span and the necessary underlying possibilities of the framework. But it turns out that if we do that, we still run into a lot of memory problems because we just have loosely defined rules that we have to adhere to, but we can't screw it up. Rust, in my point of view, I am by far no Rust expert yet. I find it a very interesting language. I'm looking into it, and I'm looking forward to my first real big projects implementing with Rust. But at the same time, even looking at this language, I immediately understood why Rust is currently in Stack Overflow's developer survey #1 loved technology, in front of every other developer technology that is currently in the Stack Overflow survey, including my good old friend C#. So I now understand why Rust is really interesting, because it combines efficiency and zero-cost abstractions with safety. And this was just the tip of the iceberg that we scratched on when looking at Rust. Rust has a lot of additional interesting features, especially for low-level, system-level programming. So Rust protects us by giving us more compile time errors and less runtime errors. And that's especially important. When you do system-level programming, think of IoT scenarios where you have to write code that runs for a long time in a very stable way. This is why I think that Rust is really a language for the future, and I'm hoping that a lot of innovation will take place there, and a lot of companies will take a look at it and maybe apply it. That is what I wanted to share with you, a little bit of comparison memory management in C# and Rust, showing you a little bit of Rust code, giving you an idea what this borrowing and ownership stuff is all about. With that, I think I've kept my time. I have 1 minute and 18 seconds left. So time management was good. My content is up. That's always a good combination if you run out of content and run out of time at the same time. I hope you enjoyed it. I'm happy to take questions, but we can also move the questions outside to the buffet and beer and drinks and so on. Thank you for having me. Thank you very much.
All right. Thanks, Rainer. Especially deep dive at the end of today. Very interesting. And yeah, maybe somebody has the opportunity to use for us or the new features of C# at some stage and present how it's worked out. Well, we're almost at the end, so I guess there's still plenty of food and drinks outside, so please guys, help yourself. I'd like to take the opportunity to say thanks to Celum. It's been a blast again. Food is great, venue is huge and massive, so thanks again. We'll definitely be back and enjoy the time, enjoy the food. Till next time.